Hi guys, in today's video we have a second order ordinary differential equation. So the general form of a differential equation of this type is d squared y dx squared plus p of x dy dx plus q of x y is equal to g of x. As you can see, this is non-homogeneous because this g of x is non-identical to 0. So in order to solve this, we would first need to find a particular solution and then find the general solution of the homogeneous equation where this is equal to 0. And after that, we add them up to find the general solution. So now we find a particular solution that we call y of p. So y of p is equal to a0 sine of ax plus a1 cosine of ax. In this case, a is equal to 1, so our y of p would be a0 sine of x plus a1 cosine of x. Now, this implies that dy of p dx, the first derivative of this, is equal to a0 cosine of x, because derivative of sine of x is cosine of x, plus a1, the derivative of cosine of x is minus sine of x, so minus sine of x. This is equal to a0 cosine of x minus a1 sine of x. Now we find the second derivative, which is d squared y of p dx squared. So the second derivative would be the first derivative of this one, which is equal to minus a0 sine of x, because the derivative of cosine of x is minus sine of x, and then we have minus a1 cosine of x, because derivative of sine of x is cosine of x. Now we're gonna substitute this, so this one, and this into the left hand side of this equation. So that would give us minus a0 sine of x minus a1 cosine of x, which is this. Then we have plus dy dx, so dy of p dx is here, so we have plus a0 cosine of x minus a1 sine of x, and then we have minus 2y, so y of p is here, so 2 times a0 sine of x plus a1 cosine of x. Now this is equal to minus a0 sine of x plus a1 cosine of x, which is this one. We put the minus in front, then plus a0 cosine of x minus a1 sine of x, then minus 2 a0 sine of x plus a1 cosine of x. This is equal to, as you can see, this one is equal to this one, so we just gonna add the coefficients. So this is equal to this, we can copy, paste it here, minus 3 times, we copy this one, now we can remove the brackets by multiplying. So we have a0 cosine of x minus a1 sine of x minus 3a0 sine of x minus 3a1 cosine of x. Now we can factorize, we take the sign here out of the bracket. So sine of x times a1 minus 3a0, and then here the cosine, so plus cosine of x times a0 minus 3a1. So this must be equal to the right hand side of this equation, which is sine of x, right? And the right hand side, which is sine of x, has coefficient 1, right? Then we can write it down as 1 sine of x plus 0 cosine of x. So as you can see, this must be equal to 1 and this must be equal to 0. So we can put them in a system of equation. So that would give us that minus a1 minus 3a0 must be equal to 1. And then a0 minus 3a1 must be equal to 0. Now if we solve this system of equation, we have that a0 is equal to 3a1, and here we have minus a1 minus 3 times a0 is 3a1, so this is equal to 1. So we have minus a1 minus 9a1 is equal to 1. This implies that minus 10a1 is equal to 1, and we have a0 is equal to 3a1. So a1 is equal to minus 1 over 10, and a0 is equal to 3 times minus 1 over 10. So we have a0 is equal to minus 3 over 10, and a1 is equal to minus 1 over 10, right? Now that we have a0 and a1, we can substitute them into this y of p, right? So we had that y of p is equal to this. So in this case, we have y of p is equal to a0. We can copy this, and now we're gonna substitute a0 and a1, right? We have a0 here and a1 here. So a0 is minus 3 over 10, and a1 is minus 1 over 10. So this is our particular solution. Now we need to find the general solution of the homogeneous equation. So the homogeneous equation, this is equal to 0. So we need to find the general solution of this. So to solve this, we let y equal to e to the power alpha x, right? This implies that the first derivative, so dy dx, is equal to alpha e to the power alpha x. This implies that d squared y dx squared is equal to, which is the first derivative of this one here, so that would be alpha squared e to the power alpha x. Now that we have this, we can substitute them into this equation. So that would give us alpha squared e to the power alpha x plus dy dx, which is alpha e to the power alpha x, then minus 2 times y, which is e to the power alpha x, is equal to 0. Now if we factorize, we have a factor e to the power alpha x on every term, so e to the power alpha x out of the bracket times alpha squared plus alpha minus 2 is equal to 0. Now if we divide both sides by this, we're gonna be left with this equation: alpha squared plus alpha minus 2 is equal to 0. And this is called characteristic equation or auxiliary equation. So now this implies that alpha, if we use the quadratic formula, we have that alpha is equal to minus 1, which is the coefficient of this, plus or minus square root of 1 squared minus 4 times this times 1, so plus 4 times 2, which is 8 over 2. So this implies the alpha is equal to minus 1 plus or minus 1 plus 8 is 9, so square root of 9 is 3 over 2. So we have two real numbers. So alpha 1 is equal to minus 2, and then we have alpha 2 is equal to 1. So we have two distinct real numbers. So the general solution would be y is equal to k1 e to the power alpha 1, which is in this case minus 2x, plus k2 e to the power alpha 2x. Alpha 2 is 1, so x, where k1 and k2 are constant, right? So this is the general solution of the homogeneous equation. Now the general solution of the non-homogeneous equation would be the sum between this general solution and the particular solution that we have found here. So the general solution of the non-homogeneous equation would be this plus the particular solution that we have found here. So this is the general solution of our non-homogeneous equation. And a was equal to 1, so this is gonna disappear. So we have sine of x and cosine of x. So this is the general solution of our non-homogeneous equation.